All right, and for our next guest, for my next trick, we have this Gibson. This is a 1966 Gibson GA-15 RVT Explorer. Now, you don't normally think of an amplifier when you say Gibson Explorer, but that's what this is. So, what do we got here? Somebody in the past had replaced this power transformer and for some unknown reason left the 2-wire power cord. They left the original filter caps in place. Obviously it's cut off, so nothing's being used, although I think this one might be used. And they've got these over here instead, so it tells me these probably aren't used. I don't know. But I think there's like 2 in here, 2 in each one of these, yeah, and 2 here. So I think this one is still in the circuit. This one replaces this. At any rate, this is going. These are going. The output transformer I've already determined is the wrong one. It's got, there's so many things wrong with this amp, I don't really know where to begin. Like I said, when they replaced this power transformer, they put the wrong one in it. So it's putting out about 100 volts more on the plate than it should. And it's been rewired so that the filaments are actually coming off of the 5 volt and not the 6.3. So we're underpowering the tubes and then nuking them. So the first order of business is, of course, we're going to get rid of these. Going to get rid of these. Going to get rid of most of all of this and replace that power transformer. And then we might be able to see what's going on with all the rest of this. But that's my first order of business with this. Anyway, one of the things I forgot to mention here, yeah, like I said, this is the 5 volt here that is supposed to go to the rectifier. Well, this has a solid state rectifier. And, you know, there's the 5 volt going to all the filaments. Here's the 6.3 right here and right here. So, whoops, I'm sorry, my camera worked, sorry. 6.3 volt here and here, totally not being used. 5 volts being used to power the filaments, which is ridiculous. And, you know, they left all this freaking wire. I mean, look at that. Now, that's bad for amp making, just to leave all that in there. But seeing that I'm going to end up inheriting this power transformer, which is a Mojo Tone power transformer. It's a fine power transformer. So it's good to have all these long leads. But, wow, yeah. So anyway, here we go. Well, here's where I am so far. New transformer is going to go in here. As you can see, they kind of hacked it up a bit. But I got everything necessary off of that tag board here. And I made this board here. Hang on. I made this board basement style, Fender basement style, that's going to sit right here in this big empty space. And my original plan was to use these 2 holes which held the original capacitors, but I forgot I've got a big freaking screw head right here and right here, and that's the output transformer, and it sits kind of right on top of it. And I had hoped I could just sit it flat to the bottom, but instead I'm going to have to put these standoffs on it. So one here, another one there, and then that'll sit more or less, whoops, well, whatever, more or less like that. I may have to redo that so that it comes around over to here. I'm going to put my bridge network right here. bridge rectifier. Diodes are going to go right here, and then that'll swing around to that. That's the center tap for the output transformer. That'll go over here where it needs to. Choke will strap across this right here. That's the choke. And those are the leads, unfortunately, are on this side. I could flip it around, but there's the original rivets, so I really don't want to flip it around. So I'll probably end up tying them off to something on the tag strip here and then running that over there. And then there's all this. So, yeah, getting there. Oh, and I took out the power. And that's going to go in there too. So, yeah, getting there. Cool. All right, well, since I was doing dry fits, I stuck the transformer in here, and yeah, I'm gonna have to do something about that. Make a little plate or something that's gonna go across here. Oh well, now you know. Now I know. But yeah, I like it. One thing I do want to mention while I've got this thing open here is the general build quality in this Gibson amp is not, vintage Gibson amp I should say, is not of the same build quality in a vintage Fender of the same era, particularly when it comes to how some of these wires are run. For instance, you have this board here. You know, you've got the metal, there's a lip, you know, a pad underneath, it's on standoffs, and then you have the upper board. But nothing that I can tell is run underneath here or underneath where the chassis is in order to get the grounding effect that you would get from the RF rejection. So we're missing that, and you got things like this, you know, this is coming over here, and then you got this long wire that's run over here, and then these two, this one goes over here, and they crisscross once you get over to this point, instead of having that nice and clean over to here. Over here, this wire should go down along the bottom and then come up and let these crisscross, but this actually goes between them, you know, and this is the sort of things that Lupe would never do at Fender. Her and her co-workers, you know, they took attention to detail, and they worried about, you know, there's a lot of crisscrossing going on right in this area where the controls are. I'm sorry, this is a terrible camera angle, but just take my word for it. This isn't quite a Fender, but that's okay. It is what it is, and I'm going to make it alive again. And just to go over here, the power transformer that I got for it is the same, that it's a Hammond, and it goes it's what they use for the Pro Juniors. What is it, 265 center, yeah, 265 volts across here. The Gibson schematic calls for 250. So, oh, and I did get the bridge rectifier in, and check it out, I'm using 3-watt diodes, so these things will never blow up. And it looks more vintage that way. So there you go. I'm going to commence on this tomorrow. It's getting about 10:30. I'm getting tired. So more on this later. All right, so wow, look what I've got. So I've got my Bassman style filter board in. My choke over here is wired to these two, and I've got some solid core wire running over here, so in and out of the choke. That's my center tap to the output transformer. That feeds my screens up here on the, you know, at 34s, 84s. I've got my HT coming off of the power transformer right here. It's should be about 265 or more volts. Into the bridge rectifier, DC out into the first filter caps, and yada yada yada, choke, da 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 da. Got my power in over here, my new power cord. Got the fuse wired up, so it goes out of there into the fuse to the switch, which is a little hard to see. and then into the output transformer, out of the output transformer to the neutral, and back out again. The ground is here, but I don't have the correct hardware to actually mount that right. Oh, and my plate. I made my little plate, and it's pretty solid. It's good. This power transformer is a little odd in that, you know, the HT is over here, but the 6.3 filament straps it on either side, as well as the mains is on either side. So I had to do a little weird stuff here. Come over here to my, twisted it once I got to this point as far as I could up here to the filaments, and it's an actual 6.3 volts instead of 5 like it was before. And this will have the correct voltage on the plates. It might be a little high, but not 100 volts high. So I'm pretty happy with where I'm at with this right now, and this looks pretty much exactly as I had pictured it in my mind. Now coming over here, I still got to figure out what all this stuff is, and I did rewire a little bit of the, remember I don't like my crisscrossy wires, so I rewired some of that over here, and I rerouted some of this other stuff. I may or may not do anything with this or that or that. I might just leave that alone, but we'll get to that. That's a tomorrow thing. I will say one thing though. This yellow wire coming over here, that is the cathodes coming off of the power tubes over here. It's a shared cathode coming over to here. That's probably going to end up going away, because they originally had their cathode resistor and the cap strapped over here going to ground. And then, however, ground makes its way back to here, which is where it ought to be. So I'm not doing that. That's going to go away. I'm going to do a much better grounding scheme in here and put things where they actually belong. So we're going to come off of here with the cathode and go directly to here with the resistor and a capacitor. And then that's for the screens, and then all the rest of the preamp stuff over here is going to go over here where it belongs. Ground. So I'm pretty happy. Like I said, this is coming along nicely. Very nice. Alright, so I finally was able to dial in the voltage on this. Part of the issue I was having is inconsistent line voltage, so I finally am just using my Variac to actually set it at 120. And then no matter where it's at, I'm getting steady readings. But anyway, I added these 100 ohms on either side to drop the voltage. I could have added a 200 over here, but if you split the load up, it actually runs more balanced. So you got the negative side on the same side as the AC and vice versa. So it, you know, it's balanced. And then I put I upped the 130 to a 200 on there, and this thing is sitting at 333 volts on the plates, and right about 10.5 watts at the plate dissipation. So I'm very happy with that. So I finally got this thing dialed in. Now, let's talk about how the stupid thing sounds. It only sounds good with everything turned up all the way. And that's the truth. If you take any of these knobs to treble and turn it down a little bit, it kind of helps. This bass knob is a complete mystery, and it's the weirdest thing ever. There's a tap on here. It's this reverse audio taper with a tap, and the tap has got a capacitor going to ground. And when you put it here, it is so thin and nasally you cannot believe it. You get it right about 4-ish, between 3, right about in that area, and suddenly you get a massive mid scoop. And then from this point on, it warms up, but by now the mids kick in, and it's nothing but mids all the way up. It is the weirdest thing. And so you can't, and then you get distortion with the mids. But it's useless. It's the most horrible thing. And you think, okay, well, you set it up, and then maybe you turn it down, right? Because I got it up all the way. No, it just sounds thin and nasally by the time you get it to that point. Even like that. I usually try to run that right about 4.5 and 8, and that up all the way. That's about as normal of a guitar tone as you're going to find. But other than that, you can't do anything with this amp. So I am going to do the radical thing and completely gut this tone stack and rewire it with something a little bit different, but I think it will be much more useful. So that's what I'm going to do to it. But before I do that, I'm going to do a before and after video and audio test, so you can tell me whether or not it was worth doing something bizarre or different, I should say, to a vintage Gibson amp that generally and traditionally sounds like hammered shit. Alright, so before I got to go to digging into this amp and changing everything, I thought it might be important to explain why it is I'm doing what I'm about to do here. And I'll have an audio test too as a before and after. I just haven't gotten to that part yet, but here's the explanation part of things. Why does this amp sound so crummy? Well, this is the schematic for this amplifier. It's with the choke, but as you can see, maybe be able to see, there are plenty of places here where Gibson is cutting the low end. There's just no warmth and no low end to this amp at all. Now, why is that? So, well, let's take a look at the very beginning here. First thing it sees before it hits the first tube here, the first triode, it's going through this 0.0047 with a 470K to ground. Now this 470K is acting as a grid leak for right here. So there's nothing terribly wrong with that. But when you put the cap in front of it, now this is a resistor, or an RC network, resistor capacitor network. And with these two values, this is cutting off at about, what did I say, 75 hertz? So we're slicing off 75 hertz from the signal right at the very get-go, literally right at the input. And then once it passes through here, you've got your bias resistor here, but you also have this 2 as a bypass cap. Fender puts in 22. That'll get you down to about almost but not quite 10 hertz. The 2 is about 250 hertz. Rolled off, you get nothing below 250 hertz. So you're slicing off 75 hertz and below. You're slicing off 250 hertz and below. And then it goes over here to the rest of the amp. This is the bizarre tone stack here that I'm about to replace. Now there's more to go in here, and I'll get to that in a second. But, well, here, I'll do it real quick. See, well, no, we're going to stay here. So what's up with this tone stack? This is the bass control. It's labeled bass, but I wouldn't call it bass because it's got, as we know, there isn't any bass in the signal. But right here, what do we have? We have this bizarre pot. It's a 2 meg reverse taper with a tap. Yes, there's a tap on the coil, on the resistor, and they have a 0.1 going to ground. Well, anything going to ground is going to roll off high end. And that's what it's doing. It's rolling off high end to this point here. This is your actual wiper. To here, they've got a 100 ohm resistor with a 500p bypass cap around it, which cuts well into the mids here. This is probably 2K-ish. It'll reach down that deep, which is why you're getting mids. And then you bounce this back and forth, and what happens is it gets to It's very, very, very thin to this point, and then you get this bizarre mid scoop right here, and then you get a little bit of warmth, and then from this point on over, you get a ton of mids. Hits a 250K. This is the treble. This is pretty standard, guitar-like. It rolls off high end to ground, but with a very, very thin .0047. So it's still, you know, it rolls off uppers, not really gets too deep. So it's not very bassy when you turn this down. And then here's the volume control that feeds into the rest of the amp. I'm going to replace this with well, I'm going to call it Fender style, but I changed everything so it's not Fender. But what else is going on in this circuit? So your signal comes in, all the low end gets cut off, all the low end gets cut off. You get it boosted up here. This is just a plate load resistor coming off the power rail. Goes through this 0.01 cap, which actually keeps all the low end that's in the system passing through, so it doesn't slice off anymore, thank God. Goes to the tone stack, but it also goes down here through this 1 meg resistor. So a very tiny piece of this thin sounding signal is now being fed all the way through here into here. Now this is the reverb circuit right here. So this comes in and it hits the reverb control, which goes into here, boosts it up, and look, here's another tone network thing we got going on. 47 and 20, 220. This RC network adds up to about, what did I say, 160 hertz. So it's slicing off yet another 160 hertz before it goes into this stage and gains it and goes into the reverb. This is the reverb tank. This is the transformer, the reverb driver, into the reverb tank, out of the reverb tank, and gains it back up again with another 2. So that's, what did I say, about 250 hertz on up. And then it slices it again, 0.0047 with a 470. Again, this is about 75 hertz cutoff before it reaches the into the phase inverter. This is the phase inverter here. This is a gain before the phase inverter. Yes, the phase inverter is a transformer in this amp. It's an interstitial phase inverter. So yeah, we're slicing off all the low end here, we're slicing off low end here, we're slicing off low end here. This is just making it sound bizarre. This is the only thing that gives it any low end at all, and it's not very much. So all of this is going away. But one other bizarre thing I'm going to change while I'm on here. Well, let's go through what I'm going to change. Okay, I already said I'm going to change off this tone stack with a Fender style. But I want to keep this here for the grid leak resistor, but I'm going to change both of these out. This is going to change to a 0.01, and this is going to be a 1 meg, and between the two, it cuts off about 30 hertz, which controls the low end. It doesn't cut off a whole lot of low end, but it just keeps them from getting too bumpy and muddy down there. I'm also going to change this to a 15. Again, Leo uses a 22. It takes it down to 10. Again, the 15, again, should cut off right about 30 hertz. So I got 30 hertz going here, 30 hertz cut off here. I'm also going to take this. If you'll notice the way this is designed right now, it comes in, signal goes on through the tone stack and comes up over here. But the reverb doesn't. It goes around the tone stack. It's totally bypassing the tone stack. So whatever you do here, it's got nothing to do with what we're sending here. So why would you want your tone control to sound one way and your reverb to sound completely different? Now, to me, that doesn't make any sense at all. So I'm going to take this, instead of it coming off right off this first stage, I'm going to bring it up over here. And it's going to be on this side of this 100K, because when this comes up, you don't want that feeding back into here. You want it going that way. So we're going to bring this feed from the other side of the tone stack, maybe before the volume control, maybe after the volume control. I haven't totally decided that yet. It's either going to be right here or right here. But at least I'm going to, whatever tone shaping you're doing here is also going to happen in the reverb. So it all sounds the same. How about that? Now, let's talk about the tone stack that I'm actually going to end up using here. So give me 1 second. All right, so here we are at the Guitar Science tone stack calculator on the web. And if you come up here, you can pull down all kinds of different manufacturers and get different tone stacks. This is a standard Fender TMB treble mid bass. Before we get into that, let's take a look at what I really want to see first. Let's look at this. This is a Fender treble bass tone stack. This particular one, we're looking at a Tremolux, but almost all Fenders use this exact same tone stack in all their amps back in the blackface days. So we're coming in, it's going through this 100K slope resistor. I think this is a 250 picofarad to the treble. It goes through another 0.1 to the bass, which is a I forget what you call that, and then 0.47 down here for the bass, and then this is a 6.8K to ground, and this is basically your mids. So if I come over here, back to my, where am I at? Hang on, sorry. There. If I come back over here, oddly enough, they don't have just the treble and bass, but they do have the TMB. But this mid control here, actually this mid control here, if you set this to 6.8K and turn it up all the way, so it's up here, that basically sets this as a static resistor, 6.8K to ground. So that's what I've done here. Now let's take a look at that. What does the standard treble, bass, and static mid look like when it's flat? The controls are on 5. Of course, I said the mids are up all the way, so I get that full 6.8K. And the basic shape looks like this. We're looking from 10 hertz to 10K, and we have this big mid scoop. That is the famous Fender mid scoop that everybody loves the way it sounds. And there's no doubt it sounds great. But I did not want to copy that strictly for this amp. So what I'm doing is I'm changing these controls and the values up here. So it's the same basic footprint. I'm just changing this value, that value, that value, that value, all these different values to get a more flat line up here. So when this, so this one here is the Fender, this one is mine. This is my tone stack up in here. And you'll see that it's flat, okay, or pretty darn flat, all right, with the controls set at 0. And then if you go turn the bass control up, the bass will go up. You turn it down, the bass will go down. This goes up, the treble will go up, this will go down. And let's see that in action here. So, all right, so let's see this in action here. So I've got my, I can go up, I can go down on my tone control. So I'm just controlling the bass. And I'm also, these are the frequencies. This is 100 hertz right about here, 200 hertz, 300 hertz. This is really where a lot of your warmth comes in. And once you get down in here, we're talking beef, okay? So you'll notice that if I turn this up, the 2 and the 300 hertz also seems to move. So I'm adding and subtracting warmth, not just beef. And that'll also come up as gain. Same thing with the treble control. Come down here, I can turn it up and I can turn it down. But when it's in the middle, it's flat. Now, what if I like that scoop? Well, I turn it up this here, I turn it up that way, and look, I got my Fender scoop. It's not entirely centered. This Fender centers their stuff on about 500 hertz. So mine is set here at about 340, 350. But if you just take this thing and you go down a little bit, say about halfway there, that's pretty much the Fender mid scoop right there. And it's louder, okay? I'm getting, what am I getting? 7 dB more all the way around. So I'm getting more gain. I still got the mid scoop, and I can also turn it down because my volume control is after the tone control. So that is the tone control that I am putting in here. And again, it's pretty much flat when everything is sitting right up the middle. And that is what I'm doing. And let's go back here. .01, 1 meg, 15, move this over to here, to this side of this 100K. Bump that up to 15, get a little more beef. I may or may not adjust down here the reverb as needed. It just depends on how woofy this ends up sounding. I can always thin it out here. There's plenty of places I can thin the tone out here if I absolutely had to. But this tone stack is going away entirely, and we're going to have a great sounding amp when this is done. So at this point in my life, I am going to do a before audio demonstration, before, you know, the way this sits right now, just with this circuit, before I change it over to that circuit. So, and then I'm going to record it. And then at the end of all this, I'll A-B the two together, and you can tell me if all of this was worth it. And if suddenly we have a good sounding amp, or did you prefer the old vintage crummy sounding amp? It's up to you.